Hello, algebra students, and welcome back to another video lesson as we continue our exploration and learning of completing the square so that we can find the vertex. Today's video is just going to be one last reminder and review of how to complete that square process. And again, I would write these examples down, make sure that you understand the process. Before we get there, I just want to make sure that we truly do have this good understanding of what is vertex form versus what is standard form, and why do we really need each one? What does it help us with? So vertex form, again, is y equals a times the group x minus h squared plus k. Standard form is y equals ax squared plus bx plus c. If we look at standard form, there are really two kind of main things that it does give us. We do have the y-intercept, and we can find the x-intercepts using quadratic formula. And so it really does help us to know that we can find that y-intercept just by looking out here at that c value. That is truly the y-intercept of the parabola. And then we can use a, b, and c in the quadratic formula. Remember, the opposite of b plus or minus the square root of b squared minus 4ac all over 2a to help us find the x-intercepts, the solutions or the roots of that parabola. We can also tell, I don't want us to forget, we can also tell if it opens up or down based on that a value. So we can tell that pretty quickly, and whether it's going to be wider or narrower. But those are the main ones for standard form. Over here for vertex form, we truly need the vertex, right? This is the first thing we should be able to get out of this equation, h comma k. And then once we know that vertex, again, we know if it opens up or down because there's the a value out front. So we know if it opens up or down, which then tells us if we have a max or a minimum. We also then know the range. We also know the axis of symmetry or the line of symmetry. We know the domain from both of them. And so we get a lot of valuable information from that vertex. And so that's why we want to find the vertex. And that's why we want to go back and forth between these two. We don't get the vertex over here at a standard form because we have y-intercepts and x-intercepts. And so we got to convert it to get vertex, max, min, range, things of that nature. And so we've learned this process called completing the square, where we have a standard form that they're going to ask us to find the vertex. And just by simply looking at it, we don't have a vertex. What we did is we tried to use those algebra tiles, where I had an x squared tile, and I'm just going to draw it right here, right? An x by an x is how I got x squared. And then we tried to make a square with this information. Okay, so x squared minus 10x plus we're going to add some blank, right? We're going to try and complete the square down here. And then we've also got to make sure we don't forget the adding 22. Now, if I have 10 x tiles, just the x tiles, those are those longer rectangular ones, we split them up in half. We put 5 of them up here. So 1, 2, 3, 4, and whoops, 4 and 5. So we're going to put 5 of the x tiles, right? So I'd have 5. And then I would put 5 the other way on the other side, so that we still have this square that we're trying to complete or fill in the hole. So I have 5 that way. So if I have 5 x's and then 5 of those x bars, how many ones, how many singles do we need in that hole down here? Well, we need 5 by 5, which is 25. Okay, so we would need 25. So I'm going to add that 25 in here. But remember, if I'm adding 25, I had to borrow them from the 22. So I really need to take away 25 from that, which leaves us with a negative 3 out here on the end, right? 22 take away, if I'm borrowing 25, we've got negative 3. Now this x squared minus 10x plus 25 turns into some quantity squared. Some quantity squared. Well, what do we have? We have an x and a 5. X and a 5 on both sides. So that's what's going to go in here. But if I want to get negative 10x, that means I needed negative 5 and negative 5, right? Each one of these was a negative 1x. Negative 1x for each one of these bars. So we have x minus 5 quantity squared. Y equals x minus 5, that quantity squared, minus 3. Now we should be able to tell the vertex. The opposite of what's in there, so 5, and then what's ever out there is my y value. The vertex is 5, negative 3. 5, negative 3. So if we just did a really quick graph, 5 to the right, negative 3 down, this parabola is going to open up because the a value is positive. Okay, so we know there's going to be two x-intercepts. We know that there's a y-intercept of 22 from standard form, right? We know it's a minimum point, and so we can tell a lot of things based off of that. But it's really about completing the square to find the vertex. Again, why do we need the vertex? Well, it's a minimum point, so that's the minimum of something. Sometimes it might be a maximum, things of that nature. Let's try a story problem. What does it look like in a story problem? So a bike store is deciding how many bikes to produce each day to minimize their costs. Their cost equation is given by the equation below. All right, helps them figure out how many bikes that they should make to minimize their cost so that they have the lowest cost possible. Minimize the cost. Well, if we're looking to minimize a cost, I am looking on a graph somewhere for where a parabola has its lowest point. And what do we call that lowest point on the parabola? We need its vertex. So this is another completing the square problem where we truly need to try and find its vertex. And if we're going to find the vertex from standard form, we need to complete the square. So we have x squared minus 20x plus some blank, we're going to put in some number here, plus 200. All right, so I'd have one box that is x by x. That's how we get the x squared. And then I've got 20 x values. So that means I'm going to have, right, half of them go this way. So 1, 2, 3, I'd have 10. Right? But in this case, it's negative 10 because each one of these has to be a negative 1x. And same thing this way. If I put 10 of them this way, I'm going to have negative 10. Right? Half go left to right and half of them go up and down to create that square. How many ones do I need to complete this square or fill this hole? Well, if I've got 10 by 10, or even in this case, negative 10 by negative 10, negative 10, now it looks like a positive, Mr. G. Negative 10 by negative 10, if I multiply those, we get positive 100. So we would need 100 of them. So I'm going to add in 100. But in order for me to add that 100 in, I've got to remember to take it away from the 200 that was already out there. So I'm left with 200 plus 100, or 200 minus 100 is plus 100. And remember this part we can rewrite as x and negative 10. And we have two of those. One's along the left, one's along the top. So x minus 10, quantity squared, plus 100. Or the vertex is 10, comma, 100. 10, comma, 100. So how many bikes should they make? C is cost, right? This is like our y. This is our cost. What do we think the x value represents? how many bikes they make. So we could say that they should make 10 bikes to minimize their cost. We want them to make 10 bikes to have the lowest cost. If they make 11 or 12 or anything lower or higher than that, their cost goes up. 10 bikes. And again, going through the completing the square process to find that vertex, because we know vertex gives us minimizing or maximizing certain values. If you have any questions, please make sure that you reach out. Otherwise, make sure you try the practice today, and good luck on the target practice.